Placing joint skeletons has always been a fundamental process of rigging a character, but what if we could automate this task? Now, what if we could achieve this for any character, pose, body shape, and even different topology? In this training series, you'll learn the industry-leading method to position your skeletons with the single click of a button. We'll start by discussing the conventional methods of joint placement and the challenges of automating this process. We'll then look at a variety of examples of different bodies and faces in a multitude of shapes, sizes, and poses, and then devise a scripted method to place these joints with incredibly high accuracy. We're not talking about the initial sizing and placement of rig templates that many packages offer. We're talking about achieving accurate placement of fine detail areas like fingers, elbows, knees, and facial joints, leaving no manual adjustment needed. The days of partial rig placement are over, and the cumulative hours spent in hundreds of assets doing this tedious process are a thing of the past. Lastly, we'll expand on this idea and discuss further processes that build on these concepts. Once you finish this series, you'll be one step closer to automating your entire rigging pipeline based simply on a model file. My name is Noah Schnapp, and I've written and optimized multiple studio pipelines, and I'm happy to share with you the industry secrets I've developed and perfected over the years. This is automatic skeleton placement in any character, any pose, and any topology. Let's jump in and change the way we forever approach rigging characters. Howdy there, and welcome to Automatically Place Joint Skeletons in Any Character, Any Pose. My name is Noah Schnapp, and I'm the head of rigging and CFX at my current studio, and I'm also a VFX workflow and pipeline consultant. And I'm happy to share with you this training series. So let's get started. In Chapter 1, we're going to be talking about how studios are placing skeletons. What challenges are they overcoming? What strategies are they using to do so? What's the difference between manual placement, pre-rigged templates, and assisted placement methods? And how can we code and create a system that can actually assist us in scan data reversal and other automatic placement benefits? We're also going to be going over the included files in this training series. Chapter 2 is going to be about discussing the logic of Skeletor. So first, we're going to be presenting the problem and devising a solution. Why do we actually need this coding application called Skeletor? Then we're going to be setting up our Maya interface and coding setup so we can have a productive environment where we can easily move code back and forth. Chapter 3, we're going to be writing our Skeletor module in Python. And so first we're going to be discussing the logic of the module by hand in Maya so we can get a good idea of how information is supposed to move back and forth, what type of data we actually want to record, what data we want to store, and how we're going to manipulate it and apply it to all of our different characters in different poses. So in order to do that, we're going to be writing a variety of functions from analyzing, recording, mirroring, and updating, and then finally the reconform functions as we move from character to character. In Chapter 4, we're going to be creating a clean front-end UI to partner with all the code that we've written. Because, we want to be able to use this code from an engineering technical point of view, but it would be wonderful if we could provide this functionality to generalists and non-technical artists. Lastly, we're going to be connecting the functions to the UI. Chapter 5 is all about body mapping, same and different topology. So we're going to have a variety of different characters that are in different poses, different topology, and we're going to look at how to actually transfer the joints to the different characters with very high accuracy. So first we're going to be looking at how to actually record the Skeletor data from a character, and then where that data lives, how it saves and reads from disk, and how it applies to all of our other characters' bodies. Then we're going to be using Wrap3D to actually map different topology and look at reconforming the different characters. And then we're also going to be looking at solutions to drive orientations of the joints in any pose. So, logical assumptions that we can make in nature based on the creature, the limb, the appendage, biped, quadruped, whether it's a face, things that we can assume that will give us the correct orientations regardless of the character's pose. After taking a look at a body example, we're going to be examining how Skeletor can be used to map a variety of faces of different size, shape, and topology. Because Skeletor is not just for bipeds, we can use this technology to handle any groups of characters, meshes, objects, anything that shares a similar skeleton. So in chapter 6, we're going to be doing the same process where we start out by recording the Skeletor data and then use Wrap 3D to map the different topology and reconform to other characters. After going through a body and a face example, you should have all the tools and logic necessary to automate the placement of your joints in any one of your characters or objects that you need to rig. Lastly, in Chapter 7, we're just going to wrap up the entire series and discuss some final thoughts about where we can go with Skeletor, what other benefits we can use this for, and how can we incorporate this into the rest of our rigging pipeline so we can really extract the full potential of this series. So let's dive in and get started.